Welcome to the Deep Dive. Today, we're taking a close look at a really core piece of kit for high-end video work.
Yeah, we're diving into the Bluefish444 EB3005M Epoch 4K Supernova S Plus lab.
Yeah.
It's fundamental for serious DI and broadcast workflows.
Right, and with a price tag around, what, $4,500? Nearly $4,600. It better be good.
Absolutely. It's built for top-tier stuff. We're talking DCI 4K resolution, 4096 by 2160.
But the spec that really jumps out is that 12-bit internal processing.
Exactly. That's the magic bullet against visible banding when colorists are really pushing the grade. Keeps things smooth.
Okay, so let's get into the hardware itself. The I/O, the connections, tells you a lot about where this lives.
It does. You've got 4 BNC connectors, and they're bidirectional.
Meaning they can send or receive signal.
Right. 3G, HD, SD, SDI video signals, and crucially, they handle ASI signals, too.
ASI being the broadcast standard for compressed streams.
Correct. But then there's this 5th BNC connector. That one's interesting.
How so? What makes it different?
Well, it's like a multi-tool for sync. It takes your standard bi- or tri-level analog gen lock.
The master clock signal for the whole facility, essentially.
Precisely. Keeps everything in time. But this same connector can also handle SDI input, ASI input, ACBU digital audio, even LTC timecode.
Wait, hang on. So the same physical port can take an analog sync pulse, or digital audio, or time code. How does it know what's coming in?
That points to some pretty smart auto detection built in. It's designed to just, work. Plug it in, lock it up, minimize fuss in a busy environment.
Okay, that makes sense. And in terms of signal quality?
It supports dual link 4.4.4 I/O, so that's full color information, no subsampling, really high fidelity.
It handles 4.4.4 RGB 8-bit and 4.2.2 YUV up to 10-bit.
Yeah, standard high-end stuff. But here's a quirk for the real power users.
Oh.
If you want the absolute top end, like say 4K 4.4.4 10-bit at 30 frames per second.
Or 4K 4.2.2 10-bit at 60 frames.
Exactly. For those, you actually need 2 of these cards working together.
Why 2? Is it just about the sheer amount of data?
Pretty much. It's all about a bandwidth. Uncompressed 4K, especially at high frame rates and bit depths, is just a massive amount of data per second.
So stacking 2 cards doubles the pipeline through the computer's PCIe bus.
Essentially, yeah. You need that combined throughput. The card itself is no slouch internally, though. Remember that 12-bit processing.
Plus 256 megs of RAM on the card itself.
And a really fast DMA engine. We're talking 1.1 gigabytes per second, full duplex.
And DMA, direct memory access, that's key because it lets the card shift all that video data straight into the computer's main memory, right? Without bogging down the main processor.
Exactly right. Bypasses the CPU bottleneck. That speed is what enables these high-fidelity, uncompressed workflows in real time.
Okay, so that speed feeds the software side. What about that?
It comes with Bluefish444's own software called Symmetry. It's mainly for Windows users.
And Symmetry is focused on acquisition and playback.
Yeah, acquisition, review, playback, tailored for 3D and digital intermediate work.
And it seems like its main strength is handling specific file types without messing them up.
Correct. It natively captures formats like Cineon, DeepZex, Targa, QuickTime, AVI, the stuff you use constantly in post.
And it manages color spaces up to 16-bit RGB internally.
Yeah, which is huge. It means you avoid those quality losses you sometimes get when converting color spaces between stages like capture, grading, and final output.
Keeps everything pristine.
And it plays nice with the big creative suites, Adobe Creative Studio, Apple's Final Cut Studio 3. It fits into existing pipelines.
Right. Now let's zoom out a bit to broadcast. You mentioned ASI support earlier.
Yeah, it has comprehensive DVB ASI support. That's asynchronous serial interface, the standard for moving compressed digital TV around.
What kind of broadcast-specific features does it have there?
Things like automatic detection between ASI and SDI signals coming in, and time-stamping of the data packets locked to that GenLock signal we talked about. Very precise timing.
Sounds critical for broadcast chains.
Absolutely. And for quality control, it has 4 built-in 1D LUTs on all the SDI outputs.
LUTs being lookup tables for applying quick color transforms for monitoring.
Exactly. Ensures what you're seeing on your monitor is accurate. Plus, it has built-in safe area and safe title generators. Shows it's really thinking about regulated delivery specs.
So summing it up, the EB3005M seems defined by, what, extreme flexibility and precision.
I think that's fair. Flexibility in signals, precision in processing with that 12-bit depth, and speed with the 1.1 GB's DMA, all across pro video and broadcast standards.
Okay. Now, you mentioned something really specific about ASI.
Ah, yes. The concept of ideal zero aperiodicity. It's a bit technical.
Break it down for us.
It basically means making sure the timing between the data packets in an ASI stream has virtually zero jitter, zero variation. It needs to be incredibly stable and perfectly timed.
Wow, the engineering to achieve that perfect clocking must be intense.
It really is, and that level of precision is fascinating.
Which leads us to a final thought for you, the listener. In a world that's increasingly moving towards IP video over standard networks, basically just data packets.
Where timing can be, let's say, less deterministic than dedicated SDI or ASI.
Exactly. So what's the long-term critical role for a device engineered for this incredible level of physical timing precision with SDI and, well, legacy ASI standards? Is that precision still paramount, or does IP change the game completely?
Something to chew on.
Definitely something to think about. We'll leave it there for this